Right, so I'm going to start supporting a few more instructions for just general SSE, VEX, EVEX instructions. So I'll create some tests here first. So we'll say SSE VEX EVEX.asm. This is 64 bits, and I want to start with comparisons for floating points. So I will start with this COMISS one. So there's a legacy VEX and then EVEX, and EVEX has this SAE decorator that I haven't implemented yet. It's sort of mostly implemented because I've already done embedded rounding, but I just need an extra flag in there to do the checks for setting the B bit in this case. So we'll create some tests for this first. So this is a COMISS XMM 0 XMM1. The other form for this is memory, so we'll do RCX here. Then we've got the VEX version, which is VCOMISS. These also just have two operands with the same operand encoding. So this one is fine as VEX, and then we've got EVEX, which I'll do 16 and 17 here to force the EVEX encoding, because EVEX is required for the high 16 out of the 32 registers that EVEX gives you. So we've got the memory one here, but we've also got SAE as a decorator that we can test as well. So if we just do the use NASM to create the test listing. And then we can take these into encoder test. So this is EVEX, and then all we need to do is create these. So we've got we'll take all of these. This becomes the op. These are all X word here. So these are V0 and V1 with NA, NA. Then this one, and this one are memory access with CX. And then this one down here has SAE, so I'll put that on the second operand here as a helper function, the same as embedded rounding. But this one doesn't take any arguments. I just need some commas on the end of these. That should be okay. So I need the mnemonics here. So this is COMISS. I need V as well. I know that I'm going to do the double version. And I know that I'm going to do the same thing for unordered. And then the other two that I'm going to cover now are shuffle PS and the same one but for PD. So I'll just take all of these and create some empty form tables for them. Okay, and then I need to add SAE, which is the same as ER, but it doesn't let you choose the rounding control. So this is SAE, suppress all exceptions. So this is going to be the same as this, but there's no need to set a value here because there's nothing to, there aren't any bits to set other than evex.b. Okay, so we need the SAE flag. And actually here, operand decorators is now incorrect. So this should be opmask zeroing, SAE, ER, and broadcast. And the operands match helper needs to do a similar check for SAE as it does for ER. So if an instructions operand uses SAE, I need to check that the form actually accepts SAE, otherwise we'll reject it. Okay, I think that should be everything. Okay, so now it can't match an instruction form for COMISS, which is fine. So we've got COMISS here. So this is going to match on the width is X word. The op-n for this is op-n-rm, because it's register, then potential memory. Op1 is vec, and then op2 can be vec or memory. And then this one has the secondary opcode map with 2f as the opcode. So map is map 0f, and then the opcode is ox2f. Then the vector version needs family vex and family evex as well. And evex needs to accept suppress all exceptions in the second operand. Okay, so I need to change the tests to use the high registers here. So now it's just SAE that isn't implemented. So if I go to the encoder and have a look for broadcast. So here I'm selecting, I'm seeing whether RM is embedded rounding. And if it is, then I set the evex.b bit and I use the RM's RC bits to select as rounding control to select the rounding mode. And actually, I don't think I mentioned this when I implemented embedded rounding, but I'm using RM here as the operand to check for things like embedded rounding, broadcast, or SAE, because although there's no rule in the Intel manual that says that these flags are related to the RM operand, every instruction I've looked at seems to be that SAE, embedded rounding, and broadcast always sort of fall on the operand that is on the third operand, which or not the third operand, the RM operand, which makes sense because setting embedded rounding, SAE, or broadcast is all about flipping the evex.b bit on, and which one it chooses, it depends on whether it's register or memory, so it makes sense that it would be on the RM operand. So I'm not supporting SAE right now, so SAE does not need to set LL to an RC, it's just whatever the form needs. So this one can just say that if RM is broadcast or it's SAE, so if it's any of these, then we flip the B bit on, and then we let LL be whatever the form says that it should be. Okay, so that's that done, and SAE is now supported. So we'll do a copy of these tests for the SD version as well. Which means that I can copy all of these tests, change them to SD. Okay, so now we need the forms. And the forms for these I'll just copy as these ones and just change this to SD. Okay, so SD just uses a prefix 66, and then this evex one has the W bit set. So if I just go to the forms, these now need, they all need the prefix 66, and then the evex one down here has the W bit set. Okay, so that's SD done. Now we'll do the U versions, the unordered versions. So this is just, looks like it's the same, but the opcode is different. It's 2E instead of 2F. So we'll go to the assembly test, make a copy of these ones, change COMII to UCOMII, or sorry, UCOMISS or SD. Then I can go and take the encoder tests. We'll just copy all of these. So this becomes UCOM. Then we just need the forms. So the forms for these can just be a copy of these ones. But we'll change COMI into UCOMI. And we'll change 2F into 2E. Okay, so next I want to implement shuffles. So we've got SHUFPS and PD. And I think these are the first ones that I'm implementing that actually use a fourth operand here. And these ones actually support memory broadcast as well. So let's use, let's create some tests for these. So we've got SHUFPS, XMM 0, and then we've got, so this has 3 operands. So this is RMI, and then the other 2 are going to be RVMI. So we've got RMI, which means I can do XMM1, and then let's just do the immediate as 7F or something. And then the M here means that I can do a memory access. I think that covers that form. Then we've got VEX, which just lets you choose the length, so that's why there are 2 forms here. But other than that, it's basically just an extra register operand. So we've got XMM 2, let's say, XMM 1. And then I just need to copy these, so I can do a YMM as well. So that's VEX, and then for EVEX, to force EVEX, I'll put these op masks on. So we'll do K1 with Z. And then for EVEX, it also supports memory broadcast as well. So this one can be 1 to 4, because it's 32 bits going into 128 bits. So I think that's okay for that test. Then we'll take a copy, make these ones YMM. Take a copy of these, and then these ones are ZMM. And let's just see if NASM's okay with this. Oh, I need to change the broadcast elements for these ones. So this is doubled the vector size, so I need to double the elements. And then this one's quadrupled it. Okay, so that's okay. And I know I'm going to do the PD version of this as well, so I may as well just do that now. Oh, and because this is PD, again, this has changed the number of elements. So the elements are now twice the size, so I have to half the elements of the broadcast here. Okay, so now let's go take all of these to the encoder test. I suppose I'll just take the PS ones and put them into the encoder test. So we've got the operation here. Then I'll just do X word. May as well just sort out these sizes first. So this is Y word. Then we've got 3 for Y word here, and then we've got 3 for Z word here. These bottom ones are going to be V0 with K1, and then the zeroing op mask. Then we've got V1, and then we've got CX memory access, and then we've got an immediate, which is OX7F. Then these top ones in each test are actually going to be V2. And then the bottom memory ones in each test are going to be a broadcast. So now these ones here are basically just going to be V0, V1, CX as a memory access, and then an immediate with 0x7F. But the top two for each size are going to be V2. And then this one is just V0, V1I, OX7F, and then NA, because this just has 3 operands in this one. And in this one, I'm just doing cx.m. Okay, I think that's all right for the test for this one. Then we'll just take a copy of these. And instead of PS, or instead of shuffle PS, it's going to be PD. Okay, so let's try running these tests. This should fail for a form. Okay, so let's go and add the forms. I'll just copy this one. Okay, so SHUFPS, the legacy version of this is XMM only, and we're going to use the operand encoding is RMI, which I think I already have. So this is R, this is M, and then the op3 must be an immediate 8. This one has no prefix, so we'll get rid of the prefix here. Map is the secondary opcode map, and then the opcode is C6. Then we've got the VEX instructions. So this one is family is VEX. So for this one, we've got the same stuff by the looks of it, but we've just got an additional operand. So this one is RRMI, or RV, so sorry, I should be looking at this table down here. This is RVMI. So RM, or RVMI, which I think I need to create as a new operand encoding. So this takes op1 is VEC, op2 is a VEC, op3 can be VEC or memory, and then op4 is the 8-bit immediate. Let's just see, I've got syntax error. Okay, that's it. Then for eVEX, it's the same thing. Oh, and actually this VEX one also has to match on Y word. For eVEX, it's the same thing, but we do Y word and Z word. And then in eVEX, we also accept in op1, we accept op mask, and we accept zeroing. And then in op3, we also accept a broadcast. And then this one is still C6, W is 0, so that's fine. Okay, and then we'll take these into PD. Let's just run the tests and see what happens at the moment. Oh, I need op-n R. So we've got RVM, I need RVMI. So in this case, we've got RVMI. So I've got a loop down at the bottom here somewhere. I've got this loop, which loops over all of the operands to try and output immediates, because there are a couple of instructions that actually have different, that have more than one immediate. So for example, I think one of them is maybe it was enter or something like that. There's like a 16-bit immediate followed by an 8-bit immediate, which is why I made this loop. So this loop will actually cover the final operand being an immediate anyway. So I don't really need another variable here. I can just keep the assignment of these variables the same, but just for the sake of correctness in the operand encoding for the form, I'll include this new encoding. Okay, so everything is fine except for SHUFPD, which I expect because I just copied the PS instructions. or forms. So this one has a prefix of 66, and EVEX sets the W bit to 1. So if we go back to the forms, so we want SHUFPD. These ones all have a prefix of prefix 66, and then the EVEX one sets W to 1. Okay, so that's comparisons for floating point values and shuffling.